on our last lesson of this unit, parametric equations. If you reference like your original calendar, I had budgeted 2 whole days for this idea, and now I'm down to 19 minutes because I won't see you tomorrow either because of your English benchmark. Luckily, this is a skill that I believe we can figure out in 19 minutes and then get a little bit of practice on it on Wednesday during our review time. But on 27, you will see a key concept box at the top of the page that defines this new big idea. Before we just dig through that, because I believe that might be a little confusing for you, I want to kind of summarize where we've been with graphs for a while and what this is going to tell us. So since maybe like Algebra 1, I don't know, maybe even middle school math, when you started graphing lines and things like that, the equations that you were given were always in the form y equals, right? Every single time. And if you wanted to go graph something, you would hit graph and y equals would come up. And what's interesting about those is they were always functions of x that you were exposed to when you were a little bitty. That's how things have been forever until this unit where suddenly I told you like, hey, guess what? You can also graph like ellipses and hyperbolas and circles and things like that. And our equations, for example, looked a little bit different. Like this is an ellipse maybe. Where this wasn't a y equals equation. Instead, it was the sum of these two terms equal to 1, right? But we've gotten really good at this lately, and you can figure out where the center is and sketch that ellipse no problem. What you're going to see today in the next few minutes is that we also have something called parametric equations, which is not like this, a function of x. It's also not like the conics we've been looking at, but instead I'm going to give you a pair of equations. One of them will be horizontal, an x equals, and the other one will be vertical, a y equals. Both will be functions of time. So that's the new piece here. Time is what we call our parameter. That's expressed right here in this box. Because we spent quite a bit of time talking through some issues on your mid-unit exam, which I'm okay with, that was a good use of time. But what I'm actually going to have to do is cut out this practice on graphing a parametric equation because we just don't have time to do it. Don't worry, I know some of you are like, what? You're not going to show me how to graph parametric equations? You'll be okay, I promise. You're not tested on graphing parametric equations. I'm going to focus on what you're tested on so that we're ready for that exam on Thursday, okay? If we have time, I'll show you how to do this on your calculator too, because that might be helpful for your test. But right now, I actually want you to go to page 29, because here's where the big issue is with parametrics that I want to make sure we have some time for. I dropped something. Oh, thanks. Thank you. Got it. Thank you. Okay, so here's what your test questions are going to look like. 2, probably. 2 questions on parametric equations. Just 2. Write x equals negative 3t and y equals t squared plus 2 in rectangular form. What I'm getting at here is I am giving you parametric, right? You see 2 equations instead of 1, and the variable is a t. That means that's a parametric set. And I'm asking you to get that into rectangular coordinates. Rectangular are what's familiar, what you've always done since you were a little bit. So I'm going to have to find a way to make 2 equations into 1. And that's how you're going to be assessed on this idea when your test rolls around on Thursday. It's going to involve this novel idea that you've never heard of before called, I don't know, substitution. And I think you'll be fine one day. But I want to show you what that looks like here and give you an opportunity to practice. This is my goal that I start, right? Y equals a function of x. When I look at my equations, I'm drawn to the y equals because that kind of looks like what I'm working towards. But this y is equal to a function of t, and I need a function of x. So I'm thinking, well, that's close, but that's not exactly what I need. Turns out, though, I've got this other equation defined for me that's really going to help me to accomplish the goal that I set out for us. Transferring this from an equation in terms of t into an equation in terms of x. So see if you can get on board with this algebraic manipulation. If x equals negative 3t, can everybody see that t is x over negative 3? Just by getting rid of the negative 3. So it turns out for this particular pair of parametric equations, I can figure out what t is pretty easily. And my goal is y equals a function of x. Anybody see what I'm going to need to do right here to finish this up? People were able to figure this out pretty quickly last class.
Instead of the c squared, you put in x over here.
Exactly. I'm going to substitute t in to the y equation. And I've got something that's rectangular, and I'm done. That's it?
No way.
Where's the hard stuff? That's it.
Get out of there.
Next question.
That's really it. I believe this would be a parabola, right, that I would see, and I would be fine with that. No biggie. So what you're really getting at in this situation is that I could graph a parabola like old school with a y equals equation. I could graph it new school with our parabolic conic form over there that we just talked about on number 6. Or now I could graph it as a pair of parametrics. But for any of these situations, I'm still just going to see a parabola. There are 2 practice problems at the bottom right here. I'm going to give you 2 minutes. I want you to try 1 and 2 down below. Please, though, my caveat, and this was something that I didn't say in first period that I needed to say. Although when I look at this first question, I see my x equals and my y equals, some of you are really like quick to jump to this second equation. Let me show you what they did first period. They were like, I got it. T is y over 4. You see what they were thinking? Mm-hmm. And they came over here and they said, okay, Blakely, so x is y over 4 to the 5th minus 5. And I said, okay, good algebra, but you are not accomplishing the task that I have set out for you. What is it that I need? A y equals. They produced an x equals because the algebra was easier in that direction. I don't care if it's easier in one way, you have to get me a y equals function in terms of x. So the question they kept asking, which I'll try and proactively address with you guys, is how do I cancel a power of 5? Yeah. How would you cancel a square?
So
Square root, so I'll use a 5th root to cancel a power of 5. I'm going to put 2 minutes on my timer and give you a chance to work. I'll come check answers as you're working. I saw Daniel first, and I'll come to you.
You guys think it's hard? No, I don't.
Try the second one.
How do you write a 5th root? How do you write a 5th root? How do you write it?
Oh, 5 on top of.
Oh, and maybe I'm not sure. Oh, man. But right here, you should add 5 or
I just did.
and I said that right. Try to.
Yeah, go to 5.
No, because I'm like, because we have the same thing. And I'm like, telling her, like, tries and
What if mine is wrong? It gives me like a lower grade.
There's that. I could even
First one's great, minor.
just put an extra T in there. Okay, so what I just saw on Cece's paper was first question, y equals 4 times, see a lot of you putting big parentheses, that's great, the 5th root of x plus 5. I don't need parentheses, but you can put them as an added like check for yourself to imply the multiplication. One thing I want to mention that Richard and I were talking about, he asked a great question. Does that radical bar need to extend all the way over the 5 or just over the x? In this case, it's got to go all the way over. Because when I'm isolating that t, the first move I would make is to add 5 to both sides and then take care of the radical last, which means the radical's got to go over everything. And I told him I could easily see myself on a test putting one multiple choice option like that and the other one with the bar all the way. So you have to make sure you're confident about your algebra so that I don't trick you. Because you know me, I'm the worst, and I always want to try and trick you. Number 2, the answer is 1. Y equals 1 over x squared minus 4.
Yes.
T comes out, expression for t goes in. Is this okay?
Yeah.
Alright, I've got one more example that I want to do for you, and then I'm going to show you some things on your calculator. Abrielle first.
For the restrictions, we just do the Xbox method?
So stating any restrictions on the domain is going to loop you back into Unit 1. I'm actually not super concerned with this, but it's a great question. Think about this, guys. If I factored that denominator real quick, I would get x plus 2x minus 2, right? Beautiful difference of squares. And what number is it that in any situation, not just this one, I can never ever divide by? 0. I'm never allowed to divide by 0. So if this is in factored form, I'm seeing really clearly then that x could never be equal to negative 2. That would generate a 0. And x could never be equal to positive 2. That would generate a 0 in the denominator. So the domain restriction would be something like all real numbers except x equals plus or minus 2. Which is a nice added extension there to recap some old information. Jeanette, yeah.
Yeah.
No. No graphing. You're good. 32. I need you to fast forward to 32. I know that makes you uncomfortable. I'm sorry. We're going all the way to 32. The explain box on 32. I have to show you something so cool right now. This is where I just am reminded how beautiful math is, and I get really excited. First, I'm going to ask all those conversations to stop so that everybody can hear how and see just how perfect all this is meant. Okay. I realize that I have to go so fast. I've been telling myself to take a deep breath and not talk really fast because that tends to stress you out. But I'm stressed out too. We have very little time for this. It's all them I hear talking. So in our previous examples, like 2 of them, we haven't done very many, but you saw parametric equations. You had an x equals and a y equals. Both components were in terms of t. Second style of parametric has these components in terms of theta. So that's a little more interesting. We're going to try to write these in rectangular coordinates. That means x's and y's instead of x's, y's, and thetas. And a really cool thing happens when I show you the manipulation on this one. I'm going to start with the x again, just like I did before. Ideas on how I can get rid of that 2? Division. How about x over 2 equals cosine of theta? I believe that based on our units in trigonometry, many of you can continue isolating right here. I would ask the question, how do you cancel a cosine? And someone would say, oh, that -1 on top of the cosine, the inverse, right? But I'm purposely going to stop right here because something beautiful is going to happen in just a second. Rather than isolate theta and substitute theta in over on the other equation, I'm going to manipulate both of these so that I have a cosine value and a sine value. I'm going to show you something awesome in a second. So let's try to replicate this with the other half. Sine of theta, what would that be equal to? Y over 4. Right? Same division on both terms. Now there was a day a few weeks ago where I taught you Pythagorean identities. It was an orange poster back there in the corner that I took down when we took our test. And there were like 3 clusters of equations, 9 in total. You remembering this? And I remember on that day I said, okay, I get that all the formulas are overwhelming. But at the end of the day, if you only walk out of here knowing one of them, it has to be this one, because it's the most important out of all of the Pythagorean identities. It's the one we'll use in calculus. You have to know this one.
Sine squared of theta plus cosine squared of theta equals 1.
Perfect. My favorite Pythagorean identity. So guess what I'm going to do? Substitution, just like before, but this time I'll substitute twice, once for sine and once for cosine. Sine comes out, sine is equal to y over 4. So I'm going to take y over 4 and square that. I'm also going to substitute in for cosine. Cosine is x over 2, and I need to square that. And both of those squares equal to 1. When I square y over 4, you ever make sure you're listening? I'm not saying this for fun, it's on your test. Y squared over 16. And here I've got x squared over 4, and all of that equals to 1. What is that? An ellipse. It reminds me of the movie when she's like, an ellipse! I feel like that right now. I got it into an ellipse. This is just an ellipse. Centered where? 0, 0. Horizontal distance from the center, what would that be? What's the 2, because 4 is actually 2 squared. What about my vertical distance? 4 and 4, so a nice vertical ellipse. It's a really kind of cool. Okay, I only have 2 minutes, but I need to show you something really quick. On my calculator. We'll mess around with this on Wednesday, but I want to get you a little preview. If I were to go to a graph screen, and the other day I showed you that when you go to menu number 3, there are actually a variety of different curves that your TIs can graph. By the way, old calculators, I can show you this on yours too. This is not just an Inspire thing, this is an everybody thing. So when I go to number 3, the other day we went to equation, and underneath equation there were all these different conics, which is great. Line, parabola, circle, ellipse, hyperbola, conic. But actually what's also cool is that number 3 on my graph entry menu says parametric. So the cool thing is I can also graph parametric curves in my calculator. And I forget what ours was. Was it x was equal to 2 cosine of theta? So 2 trig cosine of theta. Theta's in the pi button down there. And I can graph 2 cosine of theta. I can come down here and graph 4 sine of theta. Every once in a while, I'll give you an interval for t, so you'll adjust that right there based on what the problem asks. You will never adjust t step. But when I select enter, give it a second to think, and we should see an ellipse pop up. I think I'm in the wrong mode. We didn't do this on the last class, but a beautiful ellipse will pop up on your calculator. Now, before you go, sorry, I'm in the wrong mode. Before you go, I know I'm not going to see you tomorrow in pre-calculus. You are taking an English exam. But you have homework that's due Wednesday that we're going to self-score again so you can get some feedback on parametric stuff when I see you next time. I'm going to figure out what's wrong with my